Hello my dear students, how are you all? So welcome to the Karnataka YouTube channel. I hope all of you are doing good. Yes, so today I am here with another very important video as promised. Another session for KCET Maths Top 20 Tricks. This same thing part 1 has already been given to you where I talked about top 15 tricks. Okay, now we'll talk about so what is different in this session. Again, we have taken 20 different tricks, 20 more tricks I've taken, as well as apart from the short tricks, I've also taken some questions over here. So you guys just requested in the previous session that sir please add some questions and then only you explain the tricks. So I've taken that as well in the session today. We'll have a look at all of that. Okay, so let's start the session right away. Please check the first one coming for you. What is it, sir? It is on again relation and function. First topic is, please check relation and function. In that, if you are asked to, in the question, if you are asked to find 1-1 function, okay, or asked to find 1-2 function, on-to function or 1-1 function, okay, how do you gonna do that? One method is just a graphical method. Okay, so if you can draw the graph, let's say sin x is there, mod of x minus 1 is there, and if you draw the graph and you're getting what? 2 intersection over here, you're getting here 2 intersection, you're gonna say that not 1-1. Okay, if you can get only one intersection like this, a straight line, we can say this is a 1-1 function. But if you get more than one, we'll say what? Not 1-1, not 1-1. Okay, or basically also called as not injective. Okay, when you get only one intersection, we call this as to be 1-1. That's a graphical method to understand or to pick out the 1-1 function. Second is the method of derivative. So if you differentiate the given function, okay, and you get single trend, what is that trend, sir? Strictly increasing or strictly decreasing. Either of the big case, okay, either this or this, not both. Okay, so if a function is strictly increasing, you call that to be 1-1. If a function is strictly decreasing, means less than 0, not equal to, less than 0, we call the function to be again 1-1. This is clear. Okay, next for onto function, what you have to do, in the given function, put x equals to plus infinity. Put x equals to plus infinity. When you do that, if you are getting the function also equal to plus infinity, so when x is infinity, y is also infinity. And when x is negative of infinity, y is also negative of infinity. That particular function is called as onto function. Okay, it's called as onto function. X is positive infinity, y is also positive infinity. X is negative infinity, y is also negative infinity. Please check a question I've taken over here. Y equal to x square. Okay, is it onto, sir? Of course not. Please check why. Because if I take x tends to minus infinity, what happens to y, bacha? It will become square of x, right? It will become simply plus infinity. Yes or no? Yes. In that case, what will happen? Not onto, sir. Not onto. Okay, I hope this is all clear. Great. Now this is the example for your 1-1 function. So the function was given like this: y equals to x cube plus x square plus 7x plus sin x. Derivative you're going to take, you get here 3x square for this, 2x for x square, 7x will become 7, sin will become cos. Not a problem, sir. Okay, now if you check here, I can make a perfect square on this side, taking x square from here, you'll have x plus 1 the whole square, taking from here x square, 2x, and here 1. Okay, I get x plus 1 the whole square. What is left over here? I have 2x square left over here, and I have 6 left over here. Think about it. Whole square, positive or 0? 2x square plus 6, positive number, because x square is a positive number. So this is also positive. Cos x will either be minus 1 in the worst case. Even if it is minus 1, sir, it has plus 6 over here. Okay, it means it will be countering that, and of course it will be more than 0. It means strictly increasing in nature. That's why 1-1 function. So I hope this is clear how to approach a question which has 1-1 and onto, which has 1-1 and onto. Please check. Okay, so that's how we're gonna deal with it. I'm gonna remove some extra marks that I've made so that it's not confusing for you. Please check. All right, great. So let's remove this as well. I've already given the property because this notes is going to be very, very useful for all of you. That's why I want to keep this as clear as possible. Let's move on now to next set of tricks. So first 2 is here. Third trick. So before I move on to third trick, I have to ask to all of you who are into the last week of preparation of KCET, if you want to solve more questions, different type of questions, difficult level, easy level, all the categories, okay, other than the PYQs, please join Abhyas KCET test series. Okay, offer was already given to you. Okay, if you have taken in that offer, it was given at 998, but now the price has come back to 1499. What you can do is, at this price, you can take the test series and attempt as many as possible. Okay, rectify your mistakes and learn from that to get the best rank possible in the KCET examination. Okay, you get total of 35 again tests. In that 4 free was given, 31 is paid. You get detailed video solutions of all the mock test papers. You get chapter wise one-shot revision video. You get chapter wise insights for last 5 years of KCET papers. Okay, basically analysis of your PYPs for last 5 years from the KCET. Okay, now Comet K crash course is for somebody who is looking to again improve rank in the engineering college of Karnataka. So basically, and or people are from other place other than Karnataka, you have to write Comet K, right? So for Comet K crash course, we are launching from 18th of this month itself, April. So what you can do is if you take that right now at 1,999, you get 12 mock test, complete syllabus coverage of 11th and 12th. Yes, theory will be also there. 5-year previous year questions, live doubt solving sessions, class notes and recorded revision videos will be the feature of your Comet K crash course. So if you are looking to do all of that, you can call to enroll over here, or the link for this both program will be given in the description of this video. Go ahead, purchase from there right now. Okay, let's begin to our next set of tricks. We have from, please check, we have from, what is it, sir? From the chapter differentiability. From the chapter differentiability, again a high weighted chapter, please check. So no break, whenever you have no break or no sharp edge, okay, in the graph. So if there is like this, you can say non-differentiable. We have no breaks, no sharp, means we'll call the function to be simply differentiable. Okay, but if there is like this in the function y equal to x minus 1 in the mod and x plus 2 in the mod, will be non-differentiable at the point minus 2 and plus 1, minus 2 and plus 1, because you can see the sharp corners will be there like this. Okay, now what else we have? So for question number 4, sorry, trick number 4, if you're looking for derivative of a function like this, a fx plus b c fx plus d the whole square. Okay, so what are you gonna do for this? Okay, there's no whole square over here, I think. Please check, there's no whole square over here. What are you gonna do, bacha? You're gonna differentiate this. Please check. Okay, I'll do one thing, I'll just cross check. Okay, this trick. Okay, so let's for now I'm gonna keep this whole square as it is. I'll cross check for trick number 4 and let you know in the comment section whether it is having the square or not. Okay, so right now we'll keep it like this because I have made this session, I think it was square was there. So I'm not gonna solve the entire thing right now, just telling you over here. A plus you have a as a coefficient of fx, c as a coefficient of fx in the denominator. The answer will become the determinant of a b c d. Please check a b c d, and you write derivative of f over there divided by this same content. Okay, so I'll just check it over there for all of you. This one, please check. Yeah, there's no square over here, right? There's no square over here. You can see I've taken the example already. Please check, there's no square over here. So we have 3 log x plus 8. So yeah, I don't have to cross check. I have already taken example. I can say from here there's no square. So y equal to 3 log x plus 8 I have, minus 7 log x plus 9. You can check function fx is actually log x. This is my function fx, right? This is my function f of x. What is the answer going to be? Please check. AD minus BC we're going to do. What is that going to be? 3 into 9 is 27, minus 8 into 7 will become minus 56, so plus because of the subtraction right now. 9 to 3 is 27, minus 56, again there is a subtraction in the determinant, you will make this as plus 56. Derivative of log will be, sir, 1 by x, okay, and this will be the same thing, the whole square. This is the example for this, please check. Okay, now for the 5th question, for the 5th trick we have, if you have a case like this, when the function is given in the implicit form, what it means, sir? It means the function cannot be written in the subject of x or y. Okay, so function is given in the implicit form. Then what you're going to do, derivative will be given like this, minus of f of x. What does it mean, f of x? Please check, here written as fx, right? It means, sir, differentiate the function with x and y is constant. Please check, derivative of the function this f with x keeping y as the constant. Y denominator, what is it? Please check, minus is there again. Differentiate the same function with respect to y keeping x as constant. Okay, so first of all you have to differentiate with x keeping y constant in the numerator, and second in the denominator you have to differentiate with y keeping x as constant. Okay, please check, I have a question like this, x cube plus y cube plus 2xy plus sin y minus 100 was there. Okay, so what we're going to do first, differentiate this with x keeping y constant. It will become 3x square, it will become 0, it will become 2x, it will become 0. So what do we have? Sorry, 2y, right? It will become 3x square plus 2y. There's a minus sign, of course, over here. Done. Great. And for this part, please check. For this part, you'll have 0, you'll have 3y square, you'll have 2x, you'll have cos y like that. Please check. Okay, cos y like that. Great. Okay, chaliye. So this is your trick number 5. We'll move on to trick number 6. Again, whenever you have a question like this, y equal to root of fx plus like that till infinite number of terms, answer is given by, derivative is given by, please check, f dash of x upon 2y minus 1. What was the function over here? F dash of x upon 2y minus 1. Okay, now for the trick number 7, you check please here. What are you going to do? G1 into G2 into G3 up to Gn is given. So what is G1, G2, G3? They are the function, bacha. Y is also a function of x. So the derivative of y will be given by y, the same function y times of G1 derivative by G1 plus G2 derivative by G2, so on till Gn derivative by Gn. Okay, derivative of G1, so G1 dash by G1, G2 dash by G2, and then again similarly Gn dash by Gn. Okay, example, if you check here, I have this as my G1, this as my G2 like that. So please check what I'm going to write. I have to write the function value at 0, right? It will become 0 plus 1, 0 plus 2 like that till 0 plus n. If you take this in multiplication, you have 1 into 2 into 3 into till n. What is that? N factorial. I'll repeat myself. I'm looking for f dash at 0. Okay, put here 0, you'll get 0 plus 1, 0 plus 2 like that, 0 plus n. In the multiplication, you'll have 1 into 2 into 3 into all the way till n. That is nothing but n factorial. And inside you'll have, please check, derivative of this is how much, sir? 1 by 2. Over here 1 by 1 by 1, 1 by 2, 1 by 3, 1 by 4 till 1 by n. Please check 1 by n. How come n, sir? Putting this as 0. So it will become 1, 2, 3 all the way till n. Please try. If you're not sure, do this calculation. It'll be easy only. Okay, chaliye. Now from AOD chapter, very important chapter, again high weightage, and some trick questions comes from here. Okay, so AOD chapter, please check. I'm having the trick number 8 from here. Function is given like this: p sin x plus q cos x divided by r sin x plus s cos x. This is s cos x. Okay, how do you solve this? If you are having PQRS as greater than 0, determinant of PQRS is greater than 0, you can say the function is of increasing kind. Please check. This form is given to you, and they're asking for increasing, decreasing function. Okay, if you can find the determinant and get more than 0 means it'll be increasing function, less than 0 means it'll be decreasing in function. What is this, sir? Decreasing function. Please check, it is going to be decreasing function. Alright, decreasing function. Great. Now I have taken example over here. Please check. I have y equal to sin x plus p cos x, 2 sin x plus 3 cos x. They are saying is already given as an increasing function. Find the value of a. Okay, increasing means we find the determinant of the coefficient should be more than 0. Coefficient is 1 over here, p over here, 2 over here, 3 over 1p, 2, 3. Determinant will become 3 minus 2p. 3 minus 2p should be more than 0 because they have given increasing function. They have given increasing function. Hence, p has to be less than 3 by 2. Hence, p has to be less than 3 by 2. Please check. Clear, right? Very clear. Okay, AOD is done. Trick number 8 is done. Trick number 9. Total, I've taken total 20 tricks. We'll see that right now. Ninth one again from the derivative. Please check. Sorry, AOD. If you have a function like this, a sin x plus b cos x. I did a question on this trick in the live session that we had. Okay, for mathematics rank booster, please check. For this type of function, we have max as root of this same thing, the coefficient of a and b. Sorry, the coefficient of sine and cos. So a was there, a square plus b square. For max, we'll keep this as positive, and for minimum, we'll keep this as negative. So we will keep this as negative. Okay, so we have already written the negative sign there, so I'm going to erase this from here. Please check. No need. Okay, so next is going to be a favorite chapter, integrals tricks from integrals. Why favorites? Because challenging, that's why. Okay, so please check. Whenever you have this type of form, dx upon, you have a quadratic like this, ax square plus bx plus c in the denominator. What are you going to do? Answer will begin directly. Please check. This is the result. Just do one thing, check this condition. Your value of 4ac minus b square should be more than 0. Should be more than 0. When that is the case, because please check, it could be in the root, no? It has to be positive, right? So 2 upon the same condition times of tan inverse of derivative of this function by this constant. Please check. Derivative of this function by this constant, okay? And of course plus c is there. If you check the example I've taken over here, 5x square 6x plus 5. Or if you take the root of this 4ac, right? So you'll have 4 into a into c, so 5 into 4 is 25 into 4 will become 100 minus 36, 64 only. Tan inverse of this So if you look at the example, we have dx upon, please check, dx upon 5x square plus 6x plus 5, right? So what we can do, please check, 4ac will become 5 into 5 is 25 into 4 is 100 minus 6 square will be 64 only, and derivative of this part, you will have 10x for this, you will have 6 for this, so 10x plus 6, and this will repeat as it says, please check, the same thing, plus c will come, okay? Now chaliye, so this is one of the properties which you have to remember, very important, sir. Now please check 11th trick, again a very important and very useful in the case of by parts. Please check, whenever you have function like this, sin 2x times x square dx, okay, so of course you're going to take the preference order. So a will come before trigonometry, so your first function is this and second function is sin 2x, so you're going to write the first function over here, second function over here. Start taking differentiation of this one, first function, and integration of this function. I'll repeat myself, first function derivative, second function's integral, okay? So first write the functions like this, and start, first you're going to do with this step, integrate this, you'll have sin 2x as cos 2x by 2, because you'll have a minus sign, so minus sign will be there, minus cos 2x by 2 comes for integral of sin 2x, okay? And x square will become, sir, 2x, please check, okay? And you'll write the plus sign from here to here. Why, sir? Because you have to multiply this, please check. Minus 1 by 2 into x square cos 2x, yeah, that's your first term. Minus 1 by 2 x square cos 2x, okay? Second, sir, 2x and the second integration for this, cos will become sine, divide by 1 more 2, so you'll have 1 by 4. Now multiply this, but there will be a minus sign over here, there will be a minus sign over here, so you're going to get minus into minus will become plus, so plus 1 by 4 into 2x will cancel one of the 2's, you'll have x by 2 sin 2x, x by 2, you can cancel this, or 2x by 4 sin 2x. Next, differentiation, and next integration you'll have, sine will become one more time cos, and you have minus will convert to plus, 1 by 8 will be there, it was plus minus, next will become plus. Now multiply this, 2 into 1 by 8, so basically 2 by 8 cos 2x, that's your answer. This is 0, right? So don't have to do after this. It will become 0, no? 0 into anything will be 0 only, right? So we don't have to do after this. Please check. First, you're going to write the function as it is. Over here, integrate. Over here, differentiate until it get to 0. So this into this, starting from plus sign. Then this into this from minus sign. Like that, you get the result as minus x square by 2 cos 2x, 2x by 4 sin 2x plus 2 by 8 cos 2x. Have a look. 11th trick. A very useful and important trick. Okay? Saving some time. Next is bacha example on that 11th trick. Please check. When we have in this condition x power 4 and e power x dx integration, okay, x power 4 and e power x dx integration, again we'll choose first and second function. We have ex as my second function, this is my second function, and x power 4 as ate, right? So islet, if you check, algebra comes first, this comes the last at the exponential function. So we have function 2 integration will be there for the second function. Function 1 will be differentiated. X power 4 to basically 4x cube, 12x square, 24x, 24 and 0. Okay, and e power x will be always keeping as e power x only. Integration of e power x is how much? E power x. Sign will be, please check, plus, minus, and this is 0, so it doesn't matter, but it's going to be minus anyway. Okay, please check. Answer will be first one, e power x, x power 4. Next one, minus 4x cube e power x. Why minus, sir? Because of this minus. Again plus e power x, 12x square. Okay, next minus 24x e power x and plus 24 e power x. That's your result. Okay, that is your result, sir. Next, trick number 12, please check. Dx upon a plus b cos square x is there in this kind of form. Then you can directly write this as 1 by a root of a upon a plus b tan inverse of same thing tan of x. Same thing tan of x. So what is this coefficient? No, a, what is a, sir? A is the constant over here, b is the coefficient of cos square x. So a upon a plus b tan inverse of a upon a plus b. Okay, now if you have in this place, let's say if you have over here as sine square, okay, what you can do, sir, write this in form of 1 minus cos square. So basically if you have this b cos square as b sine square, no, then convert that into what you call cos square using this formula. I'm going to repeat myself. If you have cos square instead of cos square, if you have the same form in terms of sine square, convert sine square into cos square, then write this form and then use the formula. Formula is 1 by a root of a upon a plus b tan inverse of this part. Tan inverse of what, sir? This whole thing. Please check. root of a upon a plus b tan x. Please check. Same question I've taken over here, dx upon 3 plus 2 cos square x. So what is this value, sir? A value is 3, b value is 2, so 1 by 3, 3 by a plus b means 5, tan inverse of 3 by 5 tan x plus c. Tan x plus c. 13th one, whenever you have this case, e power mx sine of nx dx. Okay, again by parts is there. What is the answer going to be? E power mx by m square plus n square, e power mx by m square plus n square times m sine nx minus n cos nx. M sine nx, m for mango wala, okay, and n cos nx. Okay, chaliye. Now if you, instead of sine you have cos, so what will happen? Nothing will change. This sine will become cos, okay, this mass will become plus, and this cos will become sine. I have written the change with the help of green color. Please check. If this sine is cos, this will become cos, this mass will become plus, cos will become sine. Rest all will remain same. Trick number 14. Please check. Integral of 2x minus 1 root of x minus 1 x plus 2x minus 3 dx is there. Now by parts, the best trick of all time from integration, the question can come. So what are you going to do? Write all the factors values. So zeros you're going to write x equals to 1, x equals to minus 2, and x equals to 3. Start putting the values in the function. You get x as 1 means 2 into 1 minus 1 will become simply 1, right? 2 into 1 minus 1 will become simply 1 divided by, now wherever it is making, let's say I put 1 over here, right? It will become 0, no? Can the denominator be 0, sir? No, so ignore that part. Whatever factor is causing the 0, right? Don't take that factor. Leave that factor out. You'll have 1 plus 2 as 3 and 1 minus 3 as minus 2. 1 plus 2 as 3 and 1 minus 3 as minus 2. Please check. And whatever was taken out, ignored over here, write that in form of ln. I'll repeat myself. First write the factors, okay? And then if first start taking from the first of the zeros, take x as 1, replace everywhere x as 1, okay, in the fraction, except for where it is making 0, and whatever is, you know, ignoring that, the factor, write that in form of ln. Okay, let's say if you had ln 2x over here, you have to divide by 2. Of course, na, that's how integration works. If you have ln of ax plus b, you have to divide by a, right? So if you had ln 2x minus 1, you have to divide by 2, sir. In this case we don't have, so I'll ignore that part. Okay, chaliye. Now please check. Same way, I'm taking x as minus 2 now. So replace x as minus 2 over here, over here, over here. Because if we put it over here, minus 2 will become 0, right? So I'm going to ignore that and write this for ln. Okay. Same way, please check. If I'm writing x as 3, I'll write here 2 into 3 minus 1, 3 minus 1, 3 plus 2. 3 minus 1, 3 plus 2. I'll ignore this part and write this as ln. Okay. That's your result. Plus 3. This is, you unsimplify this, you'll get the answer. Okay. So 14th is a very important trick. Please remember, extremely important trick for the question in your case examination. Okay, done. 15th one now. This, you know, NCERT formula. Okay, you learnt in PU2. If you have ex product with fx plus f dash of x, answer is simply ex f of x. If you have this similar case, x with f dash of x, remember, it's not with the entire thing. X with f dash of x plus fx is there. Answer will be fx plus x fx plus c. X fx plus c is the result for question number 16. 17th trick now. 16th you got it right. If you had x product with f dash of x plus fx, answer will be x fx plus c. Not with the entire x. Over here ex was with entire thing. Here x is with only f dash of x. Answer will be fx plus x fx plus c. Trick 17. Okay, this one people were asking me, sir, this trick we didn't understand. Please check. If you have bacha actually like this, please check. The condition here, fx is given, and f of a plus b minus x is given. Think about it. What are you going to do? Replace x by a plus b minus x. Replace x by a plus b minus x. What are you going to get? Please check here. It will become f of a plus b minus x in the numerator. Over here, what are you going to get? F of a plus b minus x. What are you going to get for this? If you take this out, no, x will be cancelled. Sorry, a plus b will be cancelled. You'll have simply x left. Okay. So this will become this. Actually, they will interchange each other. They will interchange to each other. Okay. So in that case, answer will be upper limit minus lower limit by 2. Limit of the integration will be there. Upper minus lower limit by 2 will come. Please check over here. Example. 0 to pi by 2 is there root cot x plus root tan x dx. Okay, so if you take pi by 2 minus x, what are you going to replace? X by pi by 2 minus x. Okay, take this as integration I, okay? So you can write one more time I as this root of cot. If you replace this, it will become root of tan x, okay? Divided by this cot will again become root of tan x. This will become again root of cot x, and you have dx over here, and same integration will be there, 0 to pi by 2. If you solve, no, if you add these two, you will have 2i equals to this, and this will become same, root cot x plus root tan x by 2 tan x plus root cot x. Simply will be cancelled. You will have only dx left. What is that called as? Integration of that will be x, okay? Answer will be x by 2, right? That's why I'm saying here, answer will become pi by 2 minus 0 by 2. Basically, what is the answer going to be, bacha? Pi by 4. That's your answer. Pi by 4 is the answer, okay? Chaliye. Question number 18 now. If you have 0 to pi integration sin ax cos bx dx, the result will be 0 if a minus b is even. If this a minus b is even, so result will be 0. If it is odd, you will have 2a upon a square minus b square. Remember, the limit has to be 0 to pi. 0 to pi, sir. Is that clear? Okay. Trick number 19. If you are looking to find inverse in case of 2 cross 2 matrix, then A is given as 2 cross 2 matrix. Okay. How do you find that? Adjoint A by determinant of A. You know how to find determinant of A, not a problem. But how do you find adjoint of A? Simply interchange the diagonal elements. So move D over here and A over here. So D comes here, A comes here. Okay. And for this element, just change the sign. It will become B to become minus B, C to become minus C. C to become minus C. So interchange the element across the diagonal. AD becomes DA, and it will become minus B minus C. That is your adjoint divided by, of course, determinant of A. This is adjoint, okay? This is not determinant. Adjoint of A. Got it? Okay. Now, when we're dealing with 3 cross 3 matrix, over here, determinant you can find very easily. Only thing which is important is to find the adjoint. What are you going to do? Write the matrix. If let's say matrix A is like this, A, B, C, D, E, F, G, H, I. That's your matrix, okay? That's your matrix A, B, C, D, E, F, and G, H, I. What are you going to do? Repeat this row, A, B, C, and this row also, D, E, F, like this. Once you've done that, repeat this column over here and over here. A, D, G, A, D, check here, A, D, G, A, D, A, D, G, A, D, and this one, B, E, H, B, E, B, E, H, B, E. Once you've done that, take out the first row, first column. Now check this out. Like this you're going to make. E into I minus H into F will give me K1. And write in the first element. Please check. E into I, H into F will be my first element. Second, bacha, H into C minus I into B will become K2, second element. B into F minus C into E. C into E will become K3. Basically, you're gonna keep solving like this in the column and write the result in rows. Same way, second column will start from here. F into G minus D into I will be my K4 over here. Fourth element, and likewise you're going to continue. I into A and G into C. Next is C into D and A into F, like that, okay? D into G, H minus E into G. G into B minus H into A into E minus B into D. It's not confusing at all. We have done questions like this, okay, in my sessions. Whenever I've taught you 3 cross 3 matrix, in the board's preparation also, how to find the determinant, I've taught you this method, okay? So how to find inverse, I've used this method, so I know you that all of you know this, okay? So this completes our trick on total top 20 tricks from your KCET maths, a second session. So with this, I hope this has helped you in your preparation. But as I keep asking you all to please try, and this will be difficult to remember if you feel that way. What you can do is learn all the concepts, revise all the concepts, and after doing a couple of steps in a question, you can get the answer clearly from there also. That is one way of solving it. If you want to use the tricks, I've given you two of them, one with the 15 tricks, other with the 20 tricks. Please remember all these to be fast in the calculation in your examination, okay? Some you can see will be directly relevant in the examination, okay, because you have seen those PYQs like that, okay? So some questions might not be there in the PYQs, but it can be useful, so please remember them. Make use of these tricks and let me know how you felt. I hope to see you again very soon. Till then, take care. Bye bye.